Greetings. This video is about what's called operations with matrices. And what we're going to do is look at some simple operations like addition and subtraction, and see how these things called matrices can be involved in problem solving, looking at a couple of different scenarios. So what is a matrix? By definition, a matrix is a rectangular array of variables or constants being numbers, in horizontal rows. Left to right is horizontal, and vertical columns. Up and down is vertical. The key here is rows and columns. And then this rectangular array is usually enclosed in brackets. For example, this one that I have down here is an example of a matrix. Now, each matrix is usually represented by a letter. So maybe I will call this matrix A. Now, matrix A has dimensions. If I count the number of horizontal rows, I have 1, 2, again, the top row and the bottom row. So it has 2 rows. And then we're going to put a multiplication type of symbol there, which represents the word by. All right, by. And then we're going to count the number of vertical columns. Well, I have a vertical column here and a second vertical column here. This would be a 2 by 2 matrix. Matrices can come in all different kinds of shapes and sizes. For example, let's just define matrix B, and let's say that we want to make it a 2 by 1 matrix. What does that mean? It has 2 rows, so we'll call this A and B, and 1 column, and that would be a 2 by 1 matrix. We could also say that a matrix maybe has 3 by 1, or sorry, 1 by 3, 1 by 3. So 1, it has 1 row, let's call this 5, 2, negative 7, and 3 columns. So this would be a 1 by 3. Now, these dimensions, you guys are going to find out, are really, really important, okay? Because they determine whether we're going to be able to perform operations on them or not, okay? For example, let's jump down here to adding and subtracting matrices. In order to add and subtract, the matrices must have identical dimensions. What does that mean? I can add a 2 by 2 with a 2 by 2. I cannot add a 2 by 2 with a 2 by 3. Okay? The reason why I can't is because of the different positions that these numbers are in. We're going to talk more about that when we get to multiplication in the next lesson. But in order to add and subtract, what do I got to do? Just combine the elements in each matrix position. The elements are the individual locations or the individual numbers in there. So let's look at a couple examples here. Let's say that I have 2, 3, negative 5, 1. And I want to subtract from this another matrix. Well, this matrix is 2 by 2. In order to subtract it, I have to subtract from another 2 by 2 matrix. So I'm just going to fill in some arbitrary numbers here. Negative 3, 4, 5, and 1. Okay? And then what I get is a resulting matrix from this. Again, this matrix was also 2 by 2. And that allows me to create a resulting matrix that is a 2 by 2 matrix. My job now is to fill in the 4 elements of a 2 by 2 matrix. To fill in the first element, I'm going to go 2 minus negative 3, which would be 5. The second element, or position 1, 2, as we're going to learn it, 3 minus 4 would be negative 1. The second row, first column element would be negative 5 minus 5. Well, that would be negative 10. And then the very last element, 1 minus 1. 1 minus 1 is 0. This resulting matrix is what I get when I perform a subtraction. Okay? So let's try a couple more of these just to make sure you kind of get it. Let's say I want to take this matrix, 1, 2, 3, and I want to add another matrix to it. Now, this matrix is 1 row by 3 columns. In order to add another matrix to it, I have to have another 1 by 3 matrix. And these will be given to you, okay? Let's say this is -5, -4, and 3. I know that because I have a 1 by 3, adding a 1 by 3, I can do it, and my resulting matrix is going to be another 1 by 3 matrix. What are its elements? 1 plus -5, well, that would be -4. 2 plus -4, that would be -2. Notice how I'm leaving a little bit of space between each element. And then 3 plus 3, that would be 6. There's my resulting matrix. All right? What if I asked you to do something like this? What if I give you a 2 by 2 matrix? All right? It doesn't matter what the elements are. But let's say I have 3, 5, 7, 9. And I want to add to that a 2 by 1 matrix. Let's say this is 5, 0. Okay? 2 rows, 1 column. The problem is, if I tried to do this, I can match the 3 with the 5. But what do I do with this 5 right here? It doesn't have anybody to match to in the other matrix. Therefore, I can't, sorry about that, I can't add these. And you simply say, can't add. All right? It's not possible to add them together. All right? The last thing that we're going to do is what is called solving matrix equations. Now, there's 2 different kinds of matrix equations. One of the matrix equations would be literally implementing our idea of addition, subtraction of matrices in order to find a new matrix which they're going to define with the variable x. So in order to get x by itself in this particular problem, I know that I need to subtract this matrix 3, 2, -5, 7 from the matrix I have. That's going to leave me with what x is equal to. Now I have to ask myself, can I do it? Well, I have a 2 by 2 and a 2 by 2. Can I subtract 2 2 by 2s? Yes. So I'm going to do that, and now I have to pay attention to each element one at a time. -1 minus 3 would give me -4. 7 minus 2 would give me 5. -3 minus -5 would be 2. -2 minus 7 would be -9. My resulting matrix, or what x is equal to, would be this 2 by 2 matrix. So one of the ways that we solve these matrices is simply use them as part of a solving an equation process. The second way I've got highlighted right here on the top of the page. Sometimes they're going to tell me that 2 matrices are equal to each other, or they're equivalent matrices. What that means is each element has to match up. All right, so let me give you an example here. We'll start with a relatively easy one. Let's say that I tell you you have the matrix 5x, 4y. And that's equal to the matrix 20, 20. Now, this is a 1 by 2 and a 1 by 2. I know that these 2 matrices can match up because they're identical to each other. From here, I know this is true. I know that the first element of the first matrix has to be equal to the first element of the second matrix. In other words, I know that 5x has to equal 20. Similarly, the second elements have to match up. So I also know that 4y is equal to 20. And now I can solve this to find the values of x and y. I get x is equal to 4, and I get y is equal to 5. This is just another way that matrices can be used in order to set up or to write equations. Let me show you one more. So let's say in this example, we have 2x plus 3y and x minus 2y is equal to 312. Now, interestingly, this matrix, even though it looks like it has two pieces, it's still a 2 by 1 matrix. It's just we have an expression connected with addition and subtraction to create each of the elements. This will match up with this, 2 by 1 matrix. Let me find my eraser here. This will match up with this 2 by 1 matrix. So what do I know from this? Well, I know that 2x plus 3y has to equal 3, and x minus 2y has to equal 12. I can still solve, I just now have to remember how to solve a system of equations. The way that I'm going to solve this is I'm going to use elimination. So I'm going to multiply the second equation here by negative 2, creating a new system of 2x plus 3y equals 3, and negative 2x plus 4y equals negative 24. Smash these together, I get 7y is equal to negative 21, or y is equal to negative 3. Substitute negative 3 back in to find x. I'm going to choose to use the first equation. So I have 2x plus 3 times negative 3 is equal to 3. That's substituting y back into the first equation. This gives me 2x minus 9 equals 3, or 2x equals 12. So x is equal to 6. And I found the two values of the variables. All right, go ahead and work on the worksheet that I have on Moodle, please. And good luck. Let me know if you have any questions.